All right, today we're going to be looking at something called inequalities. So inequalities are math statements that compare expressions that may not be equal. Okay, so up until now, what we've been working with equations where everything is equal. We've been looking at the left side and the right side need to be equal to one another. And we're going to look at comparing some expressions where they might not necessarily be equal, but they're still going to have something comparing them. Okay? So we've seen these before. I know you've seen them even as early as elementary school. You've seen these symbols before. So we've got less than and greater than. And I know it's always very confusing. I always have to sometimes double check as to which one is which. So the first one that I drew is your less than symbol. And the second one I drew is your greater than symbol. Okay? Now, even though it sounds really corny, it actually does still work. You can think of your less than and greater than symbols as the mouth of an alligator, and whichever side the alligator is eating is your larger number. And as cheesy as that sounds, it does still continue to work. It's really nice. If you can't remember the exact symbol, then at least you can do that. One thing that I've seen online recently is that if you look at what is happening, the opening of the less than symbol, the opening is bigger on the right-hand side than it is on the left-hand side. So that would mean the right-hand side must be bigger than the one on the left. So the left side is less than. If you look at the one below, then obviously the left-hand side is bigger than the right-hand side, so that gives us the left is greater than. Okay? So we have those two symbols. I know you've seen those ones before. And I'm going to throw two new ones up, and they look really similar. They just have a little extra line underneath. And really all this one is saying is it could be less than or equal to. Okay, so we can have less than or equal to. And the one below that obviously then is greater than or equal to. Okay, so those are four inequalities that we're going to be using most of the time to solve our different expressions and inequalities. Okay, we do have one more, and it should be fairly simple looking at that one. That one means not equal to. We don't use that one very often in our solving, but you will definitely need to be using that one a lot as you get into grade 10, 11, 12. So the boundary point is that value that is kind of right in the middle that separates the numbers that are less than that number as well as the values that are greater than that number. Okay? The boundary point itself might or might not be included in our solution. Okay, so we'll talk about what that looks like in a little bit. As far as our graph goes, we're really just graphing things on a number line. Okay, so I'm going to have different numbers, and I'm allowed to just zoom in to whatever part of the number line that I need. Okay, so we all know that the number line, we've got our negatives on the left and 0 in the middle and all the positive numbers on the right. But we don't need to have the entire number line every single time. As long as I've got these arrows here on the ends of my number line, that's just saying that the numbers keep going forever to the left and the numbers keep going forever to the right. And I don't need to worry about including the whole number line. I just zoom into the part that I'm going to focus on. Okay, so let's look at graphing a few of these things. So if I've got something like x is greater than 12, and remember I know this one is greater because the alligator is wanting to chomp on the x, meaning x must be bigger than 12. So x is greater than 12. That 12, in this case, is my boundary point. So the 12 is my boundary point. So that means I want 12 to kind of be the focus of my number line. So I'm going to put my arrows indicating that I'm going on forever in both directions. And I'm going to put some, reasonably equally spaced lines here. And I'm just going to put 12 right at the middle. And after 12 would come 13 and then 14. And then to the left, 12 would go to 11 and then down to 10. So I've just zoomed in on the part of the number line that I'm actually interested in. And I'm interested in 12 because that's my boundary point. So I have the values that are on the left of 12 are the ones that are smaller than 12. The numbers that are on the right-hand side of 12 are greater than 12. So 12 is my boundary point. So I identify my boundary point by drawing a circle around that number. And then I use an arrow to indicate which values I want. So if we look back here, it says x is greater than 12. That means I want to show all of the numbers that are bigger than 12. So I simply go from my boundary point and I draw an arrow like this to the right. And I'm saying that all of those numbers that are bigger than 12 give me this nice statement. So my statement says that x should be bigger than 12. And that means I want to be putting in a number for x that will give me a true statement. So if I was to say something like 14, is it true that 14 is greater than 12? The answer to that is yes, that is true. So that means 14 is a value that works nicely. It gives me a true statement. If I was to do the same with the number 10, 10 is greater than 12. Does not make any sense. That's a false statement. So 10 is a number that does not work. So if you look at the red line I drew from the boundary point, that is the solution for all of the values I could substitute in for x that will give me a true statement. Okay? All right, next one. We've got x is less than or equal to 7. So again, I'm going to draw the arrows. This time my boundary point is 7, so I'm going to put my boundary point here, right in the middle. I'll give some fairly equally spaced values. So after 7, we've got 8, 9, 10, and on the other side we would have 6, 5, 4. Okay, so this one, my boundary point is 7. So I'm going to put a circle around the 7. And I need to have all of the values that are less than 7. So all of the numbers need to be smaller than 7. So I'm going to pick a number on the left-hand side. If I was to say 6 is less than or equal to 7, that is a true statement. So 6 is a number that works. If I was to try 8, 8 is less than or equal to 7. That doesn't make any sense. It's false. So 8 would not work. My values then are all the numbers on the left of 7. Now this one's a little bit different because I said x is less than or equal to 7. So if I was to actually put 7 in, is it true that 7 is smaller than or equal to 7? Well, yeah, 7 is equal to 7. In that case, I'm going to color my circle in. I'm saying that the boundary point is included in this solution. In the first one we did, if I tried to say 12 is greater than 12, that doesn't make any sense. How could 12 be bigger than 12? They're the same number. That dot at the boundary point I leave blank. I don't color it in. So the boundary point is not included. But in this one, the boundary point is included. Okay, so if your boundary point is part of your solution, you color it in, and you will color it in when you see this or equal to underneath your inequality symbol. Okay, let's do one more graph. I've got this one, 7 is greater than or equal to x. Okay, so again, I'm going to put my arrows on, and I'm going to start at 7, and then I've got 8, 9, 10. Okay, we're just zooming in on the portion of the number line we want to see. Okay, so again, my boundary point is 7. Okay, so I'm going to put my dot at 7. This one says greater than or equal to, so that means the boundary point is allowed to be part of our solution, so I'm going to color it in. And it says that 7 must be greater than x. Okay, so let's try a number. Let's try 4. Is it true that 7 is greater than or equal to 4? Well, yeah, that would work. Okay. Is it true that 7 is greater than or equal to 10? Well, that doesn't make sense. 10 is bigger than 7. Okay. So that means the numbers on the left-hand side of 7 worked, and the numbers on the right hand of 7 did not work. And actually, these two graphs look exactly the same. They had the same boundary point. They had the equals underneath the inequality, and we ended up getting the same graph, even though they are different statements. So this is why I have been in class very particular about you just not moving your x from one side to the other, because as we move into inequalities, if I move my variable from one side to the other, the expression does change. Fine. Okay. So this arrow is pointing at all of the numbers that are smaller than 9. So that means that my x values should also be smaller than 9. Now I'm not going to put or equal to because the circle was not colored in. Okay. Looking at the second example, okay, so I've got my variable again, we'll say x. Okay, it's pointing to the right hand side, so all of my numbers that I'm going to fill in should be bigger than, and the dot is colored in so it's or equal to. But what value is my boundary point at? Doesn't look as nice as the other one. It wasn't as clear. Okay. Well, since I'm working with the real number line, I'm going to look at how many lines I've put in between 4 and 5. So I want to look at what have I split my number line into. So I'm going to start here at 4. Okay, and I'm going to count over. I go 1, 2, 3, 4, 5, 6, 7. And on my 7th line, I've gotten to my next whole number. That means I've taken the distance from 4 to 5, and I've split it into 7 equal pieces. So that means each line is a jump of 1/7. And as I do my 7th jump, I've gone and added one whole number. Okay, so if I look at my boundary point then is sitting at 4 and 1, 2, 3 sevenths. So x is any number that is bigger than 4 and 3 sevenths. Okay, so remember we did that way earlier on in September. We looked at splitting our real number line into smaller portions. Okay. Now it is possible to combine inequalities. So this statement says I'm looking for all of the values that will be where x, sorry, let me say this again. I'm looking for anything where it's -3 is less than or equal to x and x is also less than 2. Okay, so -3 is less than or equal to x, which is less than 2. Okay. Well, I've got two boundary points now. I've got a boundary point at -3, and I've got a boundary point at +2. So I need to make sure both things are included. So I'll start over here with 2, and then 1, and then 0, and -1, and -2, -3, -4, -5. So my first boundary point is at -3. Okay. It says that x could also be bigger than or equal to -3, right? So -3 is less than or equal to x. The alligator is eating the x, so x must be bigger. And since it's equal to, I'm going to color that boundary point in. My second boundary point is at 2. X must be less than 2. So I'm going to identify this as a boundary point, but I'm not going to color that dot in. Now, if I look at the values that work, so let's try saying this. Is it true that -3 is smaller than or equal to -5? The answer to that would be no. Okay, it doesn't work for that first part. It is true that x is smaller than, or sorry, that -5 is smaller than 2, but -5 is not also bigger than -3. Okay, what about if I try 0? Is it true that -3 is less than or equal to 0? Yeah, that's good. Is it true that 0 is smaller than 2? Yeah, that works as well. So 0 is good. If I tried 3, right? It's true that negative 3 is less than or equal to 3, but it's not true that 3 is smaller than 2. So that value doesn't work. The numbers that work are the numbers that are in between 3 and 2. So that would be my solution. I've identified my boundary points. I draw my line in between, so I'm showing that all the values in between negative 3 and 2 work.